Welcome to Braille Institute. Today we are discussing about basis of time series. What is the purpose of time series and what are the variations has to consider? For that, I will start with one story. Story will get very easily. Will understand very easily. Once upon a time, we are the five friends went for trekking. So this is my base camp. Whoever is going to trekking will understand. We will stay in the base camp. We are the five friends will staying in the base camp. We have to travel another 10 kilometers in next day. So this is maybe my path. It's like that. Some slopes upside down is there. You have to reach. This is next campsite. You have to reach there. So truck leader asked to start the trekking at 6 o'clock. At 6 o'clock, we have to start by trekking at 6 o'clock. Morning 6 a.m. So in morning 6 a.m., my truck leader checked everybody's oxygen level. This is oxygen level. He has checked oxygen level. It was 100. So fine, everybody is fine because oxygen level is 100. It is good if it is 100. So we started trekking. So every 1 hour he has checked our oxygen level. So at 8 o'clock he again checked 96, and 9 o'clock it is 98, and 10 o'clock it is 96, and 11 o'clock it is 90, and 12 o'clock it is 96, and 13 it is 94, and 14 it is 98, and 15 it is 98. At 4 o'clock it is 16, it is 99. So every 1 hour he has checked our oxygen level. We are traveling through ups and downs is there, some meadows is there. Finally we reached in the campsite. This is my end of the day. We reached here at the 4 o'clock evening. 4 o'clock we reached here. Then it's a beautiful walking from different forest and some meadows. So after reaching here, my truck leader asked, what is the purpose of trekking? So my friend beautifully defined, trekking is nothing but we are going up for looking down. We are going up for looking down. So I structured this definition in the mind. I think about we look down. What has happened in initially at 6 o'clock? So now we are looking down. What has happened in our trekking? Start from here. So from here, what have done? Now we are observing. I'm standing here and now observing from 6 o'clock to up to evening 4 o'clock. So each 1 hour, what happened? Each 1 hour, my oxygen level is checked and notice it is 90, 98, 96, 98. So each 1 hour, he has noticed my oxygen level. So we can compare this process as a time series, because time is different time we observed a single process. In different time is increasing. Each 1 hour we observed a single process is 100, 98, 96. We observe it is continuously observing one single process in different times. It is a single process, so we can call this time series is a univariate time series. And if I analyzing my heart rate and my blood pressure, if you are analyzing different variables in different times, in each time we are analyzing these three variables, then we can call this time series will be a multivariate time series. Now I observed only one single variable, only oxygen level, observed in different time. Time is, you see the time is 1 hour gap, equally divided, equally spaced. You see, time is equally spaced from here to here. So time will be a discrete. Time will be a discrete. And what about the process, the observation process? This one is continuous. So this observation is continuous and time will be a discrete. Time is discrete. So state space, we can say it is a continuous state space. So in time series, say time will be discrete and state space will be a continuous. And we observed in at 6 o'clock, we can say it is st1. At the time of t1, our value is 100. Time of t1, my value is 100, and as of t2, at the time of t2, my observed value is 98. And what about one as of t3, it is 96. So time series I defined h of t is equal to 1, 2 up to n. Time series I can define st is equal to t is equal to 1 to t. So each time we have observed one process and noticed that process. Here I taken 1 hour gap. We can take a 1 day gap. Time we can give 1 day or 1 month or 1 year or 2 year. Time will be different, but it should be equally spaced. That will be easy to understand. Time will be equally spaced means we can easy to understand what happened in this day. So this day means end of the day. We notice the value end of the day, end of the month, and 1 year. So this is a time series and will represent as a graph. Graphical representation will understand more about the time series. How to represent this one into converting to the graph? You see, at 6 o'clock, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Here it is 90, 92, 94, 96, 98 is 100. You see, I draw my time series graph. X-axis I taken time in x-axis, and observation in y-axis. So time is increasing. Here see, time is start from 6. Time is increasing. This order should be very important. Time is increasing. We can say it's a ascending order. Time is increasing from to here. Then at 6 o'clock, what is my level was here? 7 o'clock here, 8 o'clock here, and 9 o'clock again here, 10 here, 11 o'clock it is here, and 12 o'clock it is here, 1 o'clock what is happened is again it is here, and 14 it is 98, and 15 it is 98, 16 it is 99. So like that is my graph. Each hour I have drawn what is my value. Now I am connecting these values. So I got one graph. I connected each values. So most important in the time series, this observation 100 to 100, 98, 96, this observation, it is not an independent. There is some relationship between the values. So this 96 is depend on the 98, 100, like that. There is a relationship between the values. We have to find out this relationship. It is not an independent. So you see, there is a decreasing, again decreasing. This is my graph. Now we are going to analyze this graph. What is this graph? And if you are analyzing this graph, you will understand normally we need, human being need oxygen level. This is oxygen level at least 96. We need oxygen level at least 96. If you are in below 96, then we are in out of control. You see, we are in below 96. It is a 90. Value is 90. So this is my value 90 and this 94. You see, 90 and 94. We are in out of control. We need some action here. We are out of control. We need some action. We have to take a medicine. Otherwise, we can't move further. So once we analyzed here, we understood out of control. Whether process is out of control or not. Whether our process is whether it is out of control or not. Now we understood there is a out of control. We are out of control in this situation. In this time, we need some action to recover. So main purpose, we have to find out whether this process is out of control or not. Second, we can find out the relationship between the points. Between each observation, we can find out the relationship. What is a correlation? Correlation between the points. Now it is a negative correlation. Here is increasing. Here again negative correlation and increasing. Here is again increasing. So positive correlation and negative correlation. We have to find out what is the relationship between the variables. We can construct a model. We can construct a model. With this time series, we can construct a model. How to construct a model? We analyze this graph, this process. We understand we have reached here. We are in the present state. This is my present. Presently or real time. Present time, I am in here. So we can say my present time. St is my present time. So this all is my past. You check. Presently I am sitting here. This all is my past. So how we can give values? This present time I can give it is st. Then this one what will be st minus 1. 1 hour back. This one is 2 hour back. This one is 3 hour back. Like that, if you see, this is st minus 10. So these all my past values from here to here. So I can model st. How to model st? I can model st a1 into st minus 1 plus a2 into st minus 2 plus a3 into st minus 3 plus 1 error term. How I model? This is a constant term. A1, A2, A3 is a constant term, and this st, then my present time is depend only last three values. My present st is depend only st minus 1, st minus 2, and st minus 3, and some error terms. This will explain later. So my present time is depending on the last three values. St minus t, st minus 2, and st minus. These three values and giving some value will get the my present value. This a1 may be 0.5, a2 may be minus 0.6, a3 may be 0.7, some constant value. This is maybe a 1 or 2 like that. So this is a1 and a2 and a3 are constant. So st we getting through depending on st minus 1, st minus 2, and st minus 3. So st is equal to, then what will be my st? So I can make a model. I can make a model through using this time series analyzing. Using my last three values, I make a model for the st. So construct a model. That is one of the purpose of time series. And the fourth one is forecasting. How to forecast? With these values, I can forecast another value. what will be my next value? Next value will be here, or we can predict the next value. So here you see, this is 4 o'clock. I will stand here. What will be my 5 o'clock? This is my prediction. This is my journey. What will be my 15th hour and what will be my 17th hour and 18th hour. So this prediction I can write, it is a S of t plus 1. This one I can write S of t plus 2. I'm going to predict next 17th hour. That means in and 18th hour, what will happen? How to predict? We are predicting through by using this model. How to predict? S of t plus 1. So constant of a1. So now we are, this st is make through these three values. So st plus 1, how we will make st plus 1? By using these three values. So st minus 1 will have, what will happen? It is a st, because here we given plus 1, then we are reducing 1 point a2 into st minus 1 plus a3 into st minus 2 plus error term. So I predicted, you see, I predicted my h of t plus 1 by using this past three values. S of t plus 2 I can predict by using this past. How to write it? a1 S of t plus 1 plus a2 S of t plus a3 S of t minus 1. So next value also I can predict. I can make a graph. Graph may be like that. So what is the important function? We can forecast the future. We can predict the next month what will be my sales or whatever data we are analyzing. If it is a sales, we can predict next month what is our sales. So we can predict the we can forecast the future. So this is a time series, basis of time series. Next we are discussing some variations. One of my friend is opened a missionary shop. He's opened a missionary shop. So in January, he's opened a shop in January 1st. In January, he sold 10 machines. In February, he sold 20 machines, and in March, he sold 30. In April, he sold 40 machines. So immediately I understood what will be May. So everybody understood what will be the May month. So May month is a present month. I can say ST, I call it as ST, ST minus 1 plus 10. So make a model, ST is equal to ST minus 1 plus 10. So I predict it is a 50. And what will be June? 50 plus, it is a 60. So my business is going to increase in every month. So I make a model also, and 10 is increasing in every month. Then how to draw the graph? It is January and February, March, and April, May, like that is going. So 10, 20, 30, 40, 50, 60. You see, in January for me 10. In February it is 20, and March it is 30, and April it is 40, and May it is 50, and it is going to increase. You connect the line. You see. So now you looking the graph, I understood there is a trend. in every month there is a increasing trend. So one word we studied, it is a trend. What is a trend? It is an increasing trend. We can say it is a linearly dependent. You can say it is a linear trend. So increasing trend means every month it is increasing. Here is increasing trend. There is one trend because every month it is increasing. So we have learned, we have to check whether time series graph, once you analyzing the time series graph, whether there is any trend. Sometimes trend will be decreasing, sometimes is increasing. So we have to check the trend. Here it is a linear trend. It is increasing in every month. So one more example for the linear trend. We analyze the country A. Country A population of country A in 1980 it was 10 million. 1990 it was 20, and in 2000 it was 30, and 2010 it was 40, 2020 it was 50. So it is going to increase. So every 10 year 10 million people is increasing in that country. So this population also depend on the trend. This is in this particular country. If you analyze other country, sometime will be 10 million, after 10 year maybe it is a 9 million. Depend on the country whether it is decreasing or increasing, depend on the country. This here I taken the example of linear trend. In this case population is increasing in every year. So there is some linear trend. So whenever we analyzing the time series, we have to check whether there is any trend. Sometimes trend is decreasing. So population was 100. Next 990 it is 90 and 80 and 70. Here it is 60. So you see it is a decreasing trend. So trend is decreasing. Last time we seen it is a increasing trend. And one more example, if you consider the share market, share value, I taken the one share value. This is Jan, February, March, April, and share value, when I taken my share value was $10. After 1 year my share value reached 20. I purchased this AA company share value at the $10 in Jan first one. After 1 year there is some fluctuations and something is happened, and lastly finally we reached in the here at the point of, you see we start from the $10 and at the end we ended with the $20. So there is a linear trend. There is a trend, not a linear, but there is a increasing trend. You see there is a increasing trend from here to here. This is a 1 year data we checked, then we understood there is some increasing trend. And one more example, one of my friend is selling a branded shirt. So in January he sold 100 shirts, and February he sold 150, and March it was 130, and April it was 180. So if make a model, he has make a model is st minus 1 plus zn, like that. He make a model st is equal to my present values depend on st minus 1 plus zn. If this zn is how this sudden value, sudden is equal to 50 numbers will add plus 50 with the probability of 0.6 and minus 25 with the probability of 0.4. He has defined Zn is equal to 50 probability of 0.6 minus 25 probability of 4. You see expectation of Zn. What will be expectation of Zn? Expectation of Zn 15.6 minus 25.4, it will be a 20. So I am expecting 20 units of sales should be increased. 20 units should be increased sale. 20 units should be increased. So Zn is expectation of Zn is expectation of Zn 15.6 minus 25.4. So in this case also maybe it is a decreasing, but it is a increasing trend. What is increasing? 20 units, you can say 20 of T. So 20 T is increasing trend. So we understood Zn is depend on 50 and probability of 0.6 minus 25 probability of 0.4. If you take a expectation, we understood 20 T, there is a increasing trend. 20 T, anytime 20 T will increase. So my graph will be like that, but there is a increasing trend. This will come in stationarity. For checking stationarity, we have to check whether any trend is there or not. One more example. Another example is seasonality. Seasonality. My one more friend is doing business of ice cream. You know the seasonality very well. One more, my friend is doing the ice cream sales. January, what happened? He sold out 1,000, and February he sold out 2,000, and in the March 3,000, and April 8,000, and May is sold in 10,000. Again June is come down 6,000. So you see these values at the particular time, particular 2 months of time, he has sold higher number of units. You see what will be our graph? Graph will be like that. So our graph will be increasing every month here, and we in a particular point we reached here and it's come down. You see some fixed time period there is some increasing and decreasing. So this may be affected by, this may be in the summer season, this may be in a summer, this may be in a winter. In summer season people will consume more ice cream, so his sales is increased. In winter season they consuming very less. Again summer season is coming, increased the sale. Again winter season is come, decreased sale. So we have to check once in the graph whether there is any seasonality or not. And third point, sometime in seasonality will be increasing, seasonality plus trend. Sometime our graph will be like that. So you see seasonality is there, every time is increasing, but also there is a increasing trend also there. Seasonality is present in the graph, also trend is there, increasing trend. Sometime we'll get a graph like that only. Another one is cyclic. That is cyclic. Cyclic variations. So one more friend is selling jersey. The World Cup is In World Cup time, he sold out most number of jersey. So every year, every in January he sold out 100 like that, and different month he sold out. His graph is like that. You see, there is no seasonality. Here there is some difference between seasonality and cyclic. Here is increased because maybe it is due to World Cup. The sale is increased. This jersey of football, this sale is increased maybe due to World Cup or some other cup. The sale is increased. Sometime it is come down and again sometime it is increased sale. This is depend on some country. So, for example, some countries conducting League One match and La Liga and Premier League. So, this JC sale will increase or decrease. And most important thing, there is no fixed time period. So, important point, no fixed time period. In seasonality, there is a fixed time period. How it will be seasonality will come like that. There is a fixed time period. Increasing is a fixed time period. But in this case, there is no fixed time period. Time increased in different time period. So it is, we can say it is a cyclic. And the fourth one is irregular. Irregular. Irregular is nothing. You see the graph, you will understand. There is no increasing, there is no decreasing. It's like that in share market, share price. If you see the share price, sometimes there is no increasing or no decreasing. It is going like that. We can't predict also. There is no trend seasonality. We can't predict also. So these are the four variations in the time series. Whenever we checking the stationarity, we have to check the trend or seasonality or cyclic. What are the variations is there? So this is a basic of time series. Next class I will explain the stationarity.